these changes in the sea surface temperature. And this is what this looks out plotted. And because we're looking at a differencing between Darwin and Tahiti, so you get negative numbers when Darwin is higher during El Nino years, and you will see that these correspond to what we now, through other means, look at and identify as El Nino. By the way, the Southern Oscillation, so you combine the EN from El Nino and the SO from Southern Oscillation, that's where we get ENSO. So the El Nino Southern Oscillation. It's sort of the shorthand term, that way you don't have to say El Nino and or La Nina. It's sort of the nice catch-all. So jump forward a couple decades into the late 60s. Jacob Bergnes, pardon me, wrote a paper in Monthly Weather Review where he coupled what was being seen with the Southern Oscillation with differences in the sea surface temperature and tying that into the atmosphere. And basically, so this is thought to be one of the sort of the cornerstone papers identifying what El Nino was. Jump forward another decade and a half into the early 1980s. So this is when at this time I was a lead forecaster with the Weather Service. In the operational community, we had kind of heard about something called El Nino. We had really no sense of what it was. 82-83 was arguably probably the third strongest El Nino going back to 1950. Behind, I'm sorry, probably the second strongest. 1997 probably the strongest. 82-83, and then 72-73 being the third strongest. So we're kind of hearing some things about El Nino, but the data was really muddled that year. There was actually in January of '82, there were some papers at AGU in San Francisco about this warming of the Pacific and this El Nino thing taking place, but it really wasn't an operational sort of consideration. And then that was the year of the eruption of the El Chichon volcano in Mexico. And a lot of the ash and other chemicals from that lingered in the stratosphere masked some of the IR satellite imagery that measure sea surface temperatures. So even if we had known more about it, there was still really this muddled record. So how do we now measure El Ninos? Primarily, we're looking at the sea surface temperatures. But really more than this, and this is the current one as of, I think, the 21st of October. So see this nice warm pool out here. But there's always a lot of warm water out around the dateline of the equator. So we really want to look at the SSTA, the sea surface temperature anomalies. So these yellows are above normal. The redder it gets, the more above normal it is. And so you can see this, this really warm plume, very, very classic looking El Nino occurring along the equatorial Pacific. Also some other warming up here along the Mexican coast, extending on up into the along the California and Pacific Northwest coast as well, we'll talk about. You can also look at this in cross-section. So this is a time cross-section, so November of 2014 up here, coming down to October of this year. So right up here is the date line, so you can follow the temperature along the date line. The Western Pacific hasn't changed much, but if we come down here, say along 140 degrees, so about halfway between us and Hawaii, you can start seeing this warming that really got going since about the latter part of the summer, and then progressing on through the rest of the Eastern Pacific. We also measure El Nino looking at 4 different geographic areas. The Nino 1+2 region off the coast of South America. The Nino 3 region, which extends out to almost the, to about 150 west, so about the longitude of Hawaii. The Niño 4 region, which extends from there on to 160 east. But the primary region that we look at for El Nino, it's the one that has the best teleconnection to the events that we've had, is this Niño 3.4 region. So we're taking the eastern part of Niño 4 and the western part of Niño 3, and we're sampling what the sea surface temperatures are in that area. So here are the current samplings for about the last year or so. So the Niño 4 region, again, hasn't changed very much. The Niño 3.4 region has steadily been rising since this, again, our pseudo event, El Nino event last winter, sort of stayed down below that threshold and then gradually has been climbing up to greater than 2.4, and we'll talk about that significance in a couple moments. The Niño 3 region sort of bottomed out for a little while in the spring, but now is very strong, and the same with the Niño 1+2 regions. I saw something the other day, I haven't had a chance to verify, that this is the longest time where all four regions have been greater than a half degree of Celsius above what is normal across the Pacific.
Since when?
Going back to 1950.
Really?
Yeah.
Even in 90?
Even 98, yeah.
Wasn't it?
Yeah, 98, it really ramped up much faster. It was stayed cool, and then it really took off. I think I have a graph that we can.
So it really is Godzilla.
Yeah, exactly. Another way we can look at this is looking at the sea height anomalies. So using some of the NASA satellites and also some buoys and tidal data, you can look and see how much higher the elevation of the ocean is. So as the ocean gets warmer, it expands through thermal expansion, and it actually makes the sea level higher. So this is the chart event, and this is the cool NASA graphic from from about a week ago. So all this white area looks very much like what we saw in 1997 and 98. But again, our primary area of interest we're going to be looking at is this Niño 3.4 region, and so extending from a 110 out to about a 170, I believe. And there's an array of buoys, which unfortunately are underfunded, and a lot of that data is missing still. But that is then augmented through satellite imagery of looking at sea surface temperatures. So we call this area, this 3.4 area, we look at these 3-month segments and look at what the average sea surface temperature anomaly is in the 3.4 region. If it's greater than a half degree above Celsius, it's an El Nino. If it's less than minus 0.5, it is a La Nina. Now, we further break it down. So here's our plus 0.5. So everything above this is into El Nino territory. If it gets above the 1.0, so warmer than 1 degree Celsius in that Niño 3.4 region, it falls into the moderate El Nino category. From the 1.5, greater than 1.5 gets into the strong category, into this band here. And if it exceeds the 2.0 region, it gets into what is becoming sort of a colloquial conundrum, the very strong category. Center for Climate Prediction, CPC, actually they have no document that spells this out. They all acknowledge the weak, the moderate, and the strong categories. In a couple of their bulletins, they have referred to very strong. But I started using it about 6 months ago, and it's getting more and more flavor because it does separate out as we look at some of these different El Nino events. It does separate them out. For a season to be a historic El Nino, you need to have 5 of the overlapping 3-month periods. So if we look at this top one here, this would be July. So we're looking at rainfall season. So July, August, September. So middle of the winter in here, and then on to the next summer. So this would be the June, July, August 3-month average period in that 3.4 region. Well, you need at least five of those for that season to be called a La Nina or El Nino. The criteria that I see mostly used is if you're sort of on the borderline into the next category, you need at least three of those 5 to extend on into the next category. So for example, the 1972-73 year, which is the third strongest, it only got above the 2.0 level for 1 month. So just sort of peaked up here, and then it dropped back down to 1.8 sorts of values. So that would stay in the strong category. 82 and 97 all were well above the 2.0. So here's now the breakdown that we get of all 23 El Nino events going back to 1950. Now I hopefully will have stuff I'll be posting later tonight or maybe tomorrow if I get lucky, where I have used the HAD sea surface temperature data set to go back to 1870 to have a list of El Nino events. The filtering and the averaging is slightly different than what is used by CPC, but you're going to capture at least all the events in approximately the same at the same levels. Okay, let's talk about rainfall now and El Nino. So if we look at all 23 events averaged together, and these across the bottom in all these graphs is going to be the precipitation anomaly in inches. So this lime green color in here is going to be between 1 and 2 inches above normal over these 1, 2, 3, 4 climatic regions in California. 2.0 to 3 over the region of climate zone 4 that we're in. Southern California coast is going to be a little bit higher, between 3 and 4 inches above normal. But basically, this signal was above normal California on average for the 23 events. And some of the other things to look at. Oftentimes, we will see the Pacific Northwest will be drier than normal during El Ninos. And then remember that talked about that southern tier and with the subtropical jet, or at least the enhanced jet stream across the southern tier of the United States, there's above normal spreading across the south and the southeast. But how about if we start filtering this out? If we look at, because looking at an average is always kind of tricky. Average of 23 events. It would be like saying the average temperature in San Jose on January 23rd is 68 degrees from the last 30 years of data. Well, so are we going to say this coming January 23rd is going to be 68 degrees? No, I would hope not. Well, that's what a lot of people, they look at this chart where they just amalgamate all the El Ninos together, and they say, oh, El Nino says on average California is above normal, and they forget that it is an average. If we look at just the weak El Ninos, you can see actually the pattern doesn't change a lot. Sort of lose some of this precipitation here over Texas. Big drop off though across the Gulf Coast states. We look at the moderate events, all the 6 events in the moderate category, and now you have you've sort of gone near normal. The white area is near normal, and the northwestern California, and sort of staying the same with the wettest area being across the south coast. And again, that's what we would expect with the jet across the southern tier of the United States.